Hello, everyone. Mr. Ford here with worksheet 4 of our energy packet. Just like this series of these videos previously, I'm just going to walk through brief outlines for each question or maybe groups of questions. And if you need to see details, you can check the detailed solutions in Schoology. And as usual, if you come across something, whether it's at home or in class when I'm not in class, feel free to send me a message and I'll respond to you as soon as I can, clarifying whatever questions you have. So in worksheet 4, it's kind of a mix of different things happening. In question 1, we have just a simple calculation of kinetic energy. But we do have some differing units, meaning we have 70 miles per hour and we need to convert that to meters per second. So feel free to convert that or simply look up an online calculator for the conversion. And that's pretty much it for that question. In number 2, we have another conversion of calories to joules. Calories is the food energy that we typically use. But we want to see how that relates to joules. So again, take a look in Schoology to see how that is specifically converted. In question 3, we're looking at different reference points for gravitational potential energy, MGH, or the weight of the object times the vertical displacement. And we're changing our zero mark. So just comparing the book to different levels of the problem is going to change the potential for work being done or how much gravitational potential energy it has. 4, it's a bungee cord, so we have elastic potential energy. We know the equation for elastic potential energy. We're given the K value. We're given how much the stretch is, so we should be able to simply plug that in and make that calculation. For 5, a little bit different. We're not looking for the energy, but we're looking for how fast this object's moving. So we're going to be solving for V. So be mindful of the square. We're going to have to square root our entire answer at the end. We also have the mass of our arrow in grams, which everything we plug into equations in physics, we need to have in kilograms. So make sure you make that conversion first. In 6, we're looking for elastic potential energy, but we're only given how much the spring is compressed. We're not given the K value, but we are given enough information to calculate that K value using Hooke's law, the equation we developed in the lab. So you're going to have to do that first and then plug it into our elastic potential energy equation. Oops, I think I erased the square. 7, kind of a combination of everything here. So we still have our system flow or qualitative bar graphs for energy conservation that you're going to need to complete. And then now we're adding some things. We are now looking at specifics of masses, velocities, spring constants, and displacements of springs to calculate unknown variables. For 8, we have our rock. Again, elastic, stored to go into gravitational, stored. And we want to figure out how high we can go. So plugging in both equations for those energies and then solving for the height is how you would go about that one. In 9, starting all gravitational, going into kinetic and thermal. Now, we don't have an equation for thermal, but the problem does tell us something about it. So 10% of our energy is lost due to friction, meaning 10% of what we initially started with. So that's how I get that value in the end so I can solve for the velocity. So whatever my total energy is, or really my gravitational in the beginning, 10% of that is lost due to the thermal. In 10, we kind of have a futuristic kind of thing here, where it's the work done or the energy stored in the railgun, meaning the railgun's going to do some work on some objects to launch them into space. How much work do we need? That's going to be the question that you're going to solve for, plugging in all those values. So again, feel free to take a look at Schoology on the detailed solutions. And if at that point doesn't help you, make sure you write down any questions that you need to ask next time in class. Or if you need it a little bit more timely, feel free to send me a message on Schoology or email.